Woohoo! We're the same,
but we're different.
but we're also still the same.
Okay.
And now we're going to talk about how molecules can be similar, but different. But still the same.
I like how last video really showed it. We almost could just teach it from last video.
But we're gonna do it justice.
All right. So isomers have the same number of each atom, hence the same molecular formula,
Correct.
but a different arrangement in space,
Yes.
hence different molecules that we make.
Exactly. Isomers are like Lego sets. You can build a lot of different things out of the same pieces of Lego.
Yeah.
They'd have the same molecular formula, ingredients, number of atoms of each type, but the way you put them together makes the molecule.
Right, and that is what the picture down there is trying to show you. Same number of hard carbons and hydrogens with one oxygen.
Absolutely.
So we gotta try it out, huh?
Yeah. The easiest way when you're building isomers is start with the simplest, straightest change.
Right.
And this particular example we gave to you is butane. 4 carbons, 10 hydrogens, just make a straight chain.
Right.
Really simple.
And then the easiest way to make the first isomer is to lop off that end carbon and put them in the middle.
And this is how you do that.
Okay, so if he takes off the end carbon, he's going to be stuck with a 3-carbon branch, or I'm sorry,
3 carbon
backbone, right? And then we're going to take that 4th carbon and put them up on the 2nd carbon, make a branch, fill in my hydrogens, and because we're all single bonded still, we'll find out we still have 10 hydrogens.
Yep.
And
What
we
about that name, Mr. Milks?
Oh, but we got to name this thing. Okay, we can do that. I see 3. I'm going to do the 3 straight one is my backbone. So 3 is prop, and they're single bonded, so it's ane. But on the 2nd carbon, I have a methyl group, so it's going to be 2-methyl propane. So notice the name is drastically different from 2-methyl propane to butane.
They're not the same name.
No,
They're not the same structure,
they're not the same thing.
but they are the same molecular formula, which makes them the key word of the lesson, isomers.
Isomers. Iso means same. Okay,
Mhm.
so pentane, first simplest structure, 5 carbons, there it be.
There she be.
And now we can come up with, because I have more carbons, I can do more than one side chain. So let's say with 4 carbons now, take the end one off. Let's put it on the 2nd carbon first. Here's the thing that you can't do. Okay, see where he's drawn? You can't take it on the 1st carbon and just make it go up, because all you did then is bend your
Chain.
parent chain. That's not an isomer.
Still the chain.
It's
just
still
bent.
this, right. It's just you just bent it, so that doesn't count. Okay. So now we got to fill in with our hydrogens, and then we got to name this thing. The parent chain has got 4 carbons, so I see that as a but. They're single bonded, so that's ane. And then on the 2nd carbon, I would have a methyl group, so it's 2-methyl butane.
2-methyl butane.
2-methyl
Not
butane.
the same name, not the same structure.
No, and on the next page, we can actually make an even different structure from it, and there's a different way we can go.
We're going to add a 2nd branch. So again, like we did before, we're going to chop off an end and try and branch it off somewhere else.
Yes.
So instead of a 4-carbon main chain,
We'll have a 3-carbon main chain, which is down to a prop. Now I'm going to put a carbon on either side. Fill it in with hydrogens, and we'll name this in a second as soon as he gets closer to being ready. Well, I'll just start. Prop, 3 carbons, prop, single bonded ane. But then I have 2 single carbon side chains. Can we circle those side chains just for helping us name this thing when we get that propane?
Yeah, we do it.
Sweet. So I got a methyl group there and a methyl group there. We learned in last video,
Mhm.
2 methyl groups is dimethyl, right? So I got a dimethyl propane, but I still need an address for those for the methyls, and it's 2,2. We don't just say 2-dimethyl and assume. We do 2,2-dimethyl propane.
Yeah, that's it.
Cool.
Any other isomers we should give a shot?
What I want to make sure we know is that if we were to have that last one, if I go back, do you think it's still there?
Oh, yeah.
It is still there. Sweet. So notice he took that end carbon and he popped it up on top. If you were to take that methyl group that he put there onto and you would have put it up top, it would still be 2-methyl butane.
Right.
If you were to take that methyl group and move it over to the 3rd carbon, if I counted from the other way, it would still be 2-methyl butane.
Yeah.
So you don't have a lot of choice to move the side chains around yet with this particular piece. You really got to break off the main branch and build another branch.
I think isomers are really going to click once you get your hands on a model kit,
And you start playing.
because you'll see that it's not different if you move it to certain spots. It only becomes different if you move it to the middle of the chain.
Yeah. The end just bends. You can see you can just twist those sometimes.
Yeah.
And I didn't do anything differently. I just kind of twisted it. So have fun practicing with this one, guys.
Definitely. Even ask for a model kit to help your practice. To be
Absolutely.
totally honest, this is a very kinetic thing. You got to get your hands on these, rotate them in three-dimensional space so that you can see moving branches around doesn't always make a different molecule, but sometimes it does. And those are the isomers because they're the same, but different.
Yep. And it helps us figure out which numbers we should name the carbons. It helps us with a number to
Very much hands-on. Thank you.
We've got a short one.